All right, so we're going to get started with a new unit, Chapter 7, which is about exponential functions. Now, we have spent, in this class, we've talked about linear functions, we've talked about quadratic functions, but this is the first time that we're going to be talking about something where the exponent is actually where the variable occurs. So if you look here, you can see on this slide, which you've had a chance to read, you'll see that we have our base, which is right here, I'll circle it for you. And then we have our exponent, which you notice in the exponent is the variable, so something brand new. And we'll come back to the slide in a few minutes, but I want to go ahead and show you what the graph of these looks like. So we've already talked about linear functions, that's a line, quadratic functions, that's a parabola. So we need to talk about what an exponential function is going to look like. So I've got these two examples here, these parent functions, if you will. And I'd like to show you what they look like. So I've asked this before in this class, but if you don't know what a graph of a function looks like, what should you do? And you should always plug in points. So we're going to make a little t-chart here and plug in some values for x, figure out what you get in the function when you plug that in, and plot the points. So let's start with 0. Now anything to the 0 power, because notice our 0 is going to be in our exponent, anything to the 0 power is going to be 1. So I'm going to plot 0, 1. And then as I move to the right, if I plug in 1, that's 2 to the first power, so that will be 2. So I plot 1, 2. Then if I keep going to the second power, 2 to the second power is 4. And finally 3, so 2 to the third power is 8. All right, now we could keep going to the fourth power, to the fifth power, to the sixth power, but you'll notice that we'll be off of our grid. So when we draw this curve here, we put an arrow at the end saying it goes on forever. All right, so that should at least be a little bit familiar from our parabola days with quadratics. So now if we move to the left of 0, so if I plug in like -1, we need to talk about what happens with that. So I'm just going to show you up here. If you think back to Algebra 1, anytime you raise a base to a negative power, you actually need to put that all in the denominator and it becomes a positive. So it actually would be 1 over 2 to the first power. So that would be 1/2, which is 0.5. So when I plug in -1, I get 0.5. If I plug in -2, you'll get 1/4, right? 1 over 2 squared, so that's 0.25. You can see that if we keep going, we would actually get closer and closer to 0, 1/8, 1/16, all the way going forever to the left, but we would never touch it, right? 1 over 2 to a really high number is still going to be really, really, really close to 0. Very small, but not actually 0. So if you notice in my line here, excuse me, my curve, the arrow doesn't actually, or the curve doesn't actually touch 0. The arrow says it's going on forever but never touches. So this in red is what we would call an exponential growth function. So just like you read a book from left to right, if you start at the left, put a little dot here, starting from the left and moving to the right, you would see that I am, even though I'm slowly increasing at first, then as I cross 0 and move up towards the last points that I plotted, you would see that I am increasing the whole time, even though it's a very small increase to a larger increase. I'm still increasing the whole time, which is why we say exponential growth. All right, so now I'm going to switch to blue, and this other one over here, 1 over 2 to the x power, another t-chart, and let's see what happens with that. Again, to the 0 power, I don't care what my base is, 1/2 or 2, whatever it is, anything to the 0 power is 1. So if you notice, they actually both share that point of 0, 1. But this time when I plot 1 and 2, right, for my x values, I'm going to have 1/2 to the first power, which is still 0.5, and 1/2 to the second power, so that's 1/2 times 1/2 is 1/4 or 0.25. So I'm actually going to be getting closer and closer to 0 as I move to the right of 0 this time. So closer and closer without ever touching it. All right, so when I move to the left or to my negative x values, so I'm going to show you this one to the negative first power. Again, Algebra 1, if you have a fraction raised to a negative power, you take the reciprocal of the fraction, so notice how it's flipping over to 2 over 1, and the power becomes a positive. So 2 over 1 to the first power is 2. All right, so I'm going to plot -1, 2. And if I plot x5 negative 2, that will be 4. And you'll notice that this is going to be the reflection of the growth function. So you see they're the same distance from the y-axis. All right, so again, left to right. So I'm going to go ahead and show you left to right. So black dot to black dot, left to right, you'll see that we are decreasing the entire time. So that's why we call the one in blue is exponential decay. So now what you guys have to determine is how do we know when it's growth and how do we know when it's decay? So if you back up a slide to where you read this information about exponential functions, I want you to hone in on that bottom paragraph. All right, in that bottom paragraph, it tells you that if you have a b value that's greater than 1, it will be growth. And if it's a b value that's between 0 and 1, it will be decay. All right, again, our b value is our base, which I've already circled. I don't care what's in front of the base. The exponent for now is just going to be the variable x or whatever variable it is. But that's how you're going to decide if it's going to be growth or decay. What is the value of the base? All right, so I'm going to go ahead and let you guys stand up, go to your boards so you can figure out for these four if it is growth or decay.